Assalamu alaikum everyone. In this video we will get to know about different types of sets. Let us start with the first type of set, that is finite set. It is a set containing a specific or limited number of elements, just as we have this set P is equal to 2, 3, 5, 7, that is the set of first 4 prime numbers. Then we have infinite set, that is a set containing unlimited number of elements or uncountable number of elements. We have C is equal to 4, 6, 8, 9, 10, 12, and then we have 3 dots which show that the set has a continuation. This is the set of all the composite numbers. Then we have a set of integers that has dots on both the ends and show that the set is endless from the start as well as from the end. Then we have null or empty set. It is a set containing no elements at all. A null or empty set is also denoted by the symbol phi. For example, we have the set of whole numbers less than 0. That is an empty set because there are no whole numbers less than 0. If a set contains the symbol phi, it is not an empty set as it contains one element, that is the symbol phi. Then we have singleton set, that is a set containing a single element. For example, we have A is equal to December or B is equal to X such that X is an even prime number. We all know that there is only one even prime number, that is 2. So it is a singleton set. Now we have some questions related to finite and infinite sets. Here we need to state which of the given sets are finite and which are infinite. The months of a year. Well, we all know that there are 12 months in a year, so it is a finite set. Then we have W is equal to 0, 1, 2, 3, 4, 5. Well, this is a set of all the whole numbers, and the dots at the end indicate that the set is continuing. So it is an infinite set. Then we have Y is equal to X such that X is a multiple of 2. Well, there is no limit on the multiples of a number, so it is an infinite set. Then we have the lines passing through a point. Well, we cannot count the number of lines passing through a point, so it is an infinite set. Then we have the lines passing through 2 given points. Well, only one line can pass through 2 given points, so it is a finite set. I hope that after doing these questions, you will be able to distinguish between finite and infinite sets. Our next question is related to empty sets. Here we are required to state whether the given sets are empty sets or not. The first one is penguins living in Sahara Desert. Well, it is quite obvious that penguins cannot survive in a desert, therefore it is an empty set. Then we have even numbers divisible by 3. Well, even numbers are only divisible by 2. Therefore, it is also an empty set. Then we have multiples of 2 that are divisible by 4. Well, this is not an empty set because there are multiples of 2 that are divisible by 4, such as we have 2 into 2 is 4, or we have 2 into 4 is 8. 4 and 8 are divisible by 4, so it is not an empty set. Then we have 2-digit numbers greater than 99. Well, 99 is the greatest 2-digit number, and after 99 we have 3-digit numbers. So this is obviously an empty set. Then we have buses having more than 30 seats. Well, we can find buses having more than 30 seats, so it is not an empty set. Here we have another question that is related to empty sets. Here we are required to state whether each of the given set is an empty set, and we are also required to list down all the elements in set notation. A is a set of odd numbers divisible by 2. Well, there are no such odd numbers which are divisible by 2. Therefore, it is an empty set. Then we have W is equal to X such that X is a month of the year having less than 30 days. Well, we have February that has 28 or 29 days, so it is not an empty set. Then we have T is a set of triangles with 5 vertices each. Well, a triangle cannot have 5 vertices, it has 3 vertices, so it is an empty set. Then we have P is equal to X such that X is an even prime number. Well, we know about that. An even prime number, that is 2, so it is not an empty set. Moving on, we have equal and equivalent sets. Well, equal sets are the sets containing exactly the same elements, and we use the symbol equals to denote equal sets. Here we have A is equal to 1, 2, 3, 4 and B is equal to 2, 1, 4, 3. If you notice, these are the same elements that are stated in B, but the sequence is different. So A is equal to B. Here it must be noted that if A is equal to B, then the number of elements in set A are equal to number of elements in set B. Here you must remember that for two sets to be equal, not only the number of elements but also the elements should be same. Then we have equivalent sets. These are the sets having one-to-one correspondence between their elements, that is, they have the same number of elements, and it is not necessary for the elements to be same. We have A is equal to A, B, C and B is equal to 1, 2, 3. As the number of elements are same, so A is equivalent to B. It is to be noted that if two sets are equal, they are also equivalent, but two equivalent sets may not be equal. Here we have a question that is related to equivalent sets. In the first one, we have a pair of sets. A is equal to 1, 2, 3, 4 and B is equal to A, B, C. Well, these cannot be equivalent sets because the number of elements differ. Then we have W is equal to X such that X is a whole number less than 7. Well, this set includes all the numbers from 0 to 6. Then we have D. D is the set of days of a week, that is Monday, Tuesday, Wednesday, Thursday, Friday, Saturday and Sunday. As both the sets have the same number of elements, therefore these are equivalent sets. Then we have O is equal to addition, subtraction, division and multiplication symbols. C is equal to A, B, C, D and E. As you can see that the first set has the mathematical operations and the second set has the first 5 letters of the English alphabet. But as the number of elements is different, therefore these cannot be equivalent sets. Then we have set of first 5 consonants of English alphabet, that is B, C, D, F and G. And the second set is set of composite numbers less than 13, that is 4, 6, 8, 9, 10 and 12. As the number of consonants is 5 and the number of composite numbers less than 13 is 6, therefore these are not equivalent sets. Then we have M is equal to January and Y is equal to month of the year starting with D. Well, there is only one month that starts with D, that is December. As both the sets have one element each, therefore these are equivalent sets. Then we have the final pair of sets. A is equal to X such that X is a prime number less than 13. Well, the prime numbers less than 13 are 2, 3, 5, 7 and 11, which are 5 in number, and B is a set of vowels A, E, I, O, U, which are also 5 in number. So A and B having same number of elements are equivalent sets. I hope that now you have a clear idea of equivalent sets. Subset is another type of set that we have. Given two sets A and B, we say that B is a subset of A if every element of B is an element of A. From the definition of a subset, we can say that every set is a subset of itself and null or empty set is a subset of every set. Then we have power set, that is a collection of all the possible subsets. If A is equal to AB, then to find the number of possible subsets, we use the formula 2 is to the power n. As the number of elements here is 2, we write 2 is to the power 2, that is 2 into 2, 4 subsets. As null or empty set is a subset of every set, first of all we will write a null set, then we will write A, and then we will write B, and finally we will write A, B together. So we are having 4 subsets of the given set A. It is to be noted that power set of an empty set is not empty because it contains one element, that is the set itself, the empty set itself. Here we have a question that is related to power sets. If A is equal to 1, 2, 3, 4, find the power set of set A. Here the number of elements is equal to 4. Therefore we have 2 is to the power n, that is 2 is to the power 4, 2 into 2 into 2 into 2, that is 16 subsets. We will start with the null or empty set, then we will write 1, 2, 3, 4 separately, and then we will pair them together. We will write 1, 2, then we will write 1, 3, then we will write 1, 4. Then we will write 2, 3 and 2, 4, and then we will write 3, 4. That is, we will keep pairing one number with the other numbers. The idea here is to move forward, we will not move backward. After pairing two numbers together, we will make pairs of 3. We will fix 1 and 2 and we will make a pair with 3, that is 1, 2, 3, and then we will make a pair with 4, that is 1, 2, 4. Then we will fix 1 and 3 and we will pair it with 4, we have 1, 3, 4. Then we will write 2, 3, 4, and finally we will write all the 4 elements, that is 1, 2, 3, 4. If you count all of these subsets, these are 16 in number. Here we have two more types of sets, that is proper subset and improper subset. A is said to be a proper subset of B if every element of A is an element of B and there is at least one element of B that is not in A. As you can see over here, A is equal to 1, 2, 3 and B is equal to 1, 2, 3, 4, 5. That is, every element of A is an element of B and B has two more elements, that is 4 and 5, that are not in A. So A is a proper subset of B. Then we have improper subset. That is a subset which contains all the elements of the original set. That is, A is equal to 1, 2, 3 and B is equal to 3, 1, 2. Only the sequence is different but the elements are same. So here we can say that A is an improper subset of B, or we can say that B is an improper subset of A. It is to be noted that while proper subset contains few elements of the original set, improper set contains every element of the original set along with the null set. Now we have disjoint sets, which are the sets containing no common elements. That is, the elements of disjoint sets are totally different. A is equal to 1, 2, 3 and B is equal to 4, 5, 6. That's why these sets are drawn separately. As you can see the two circles over here, A set contains 1, 2 and 3 and B set contains 4, 5 and 6. Also, if A is equal to x such that x is a prime number and B is equal to x such that x is a composite number, then these are disjoint sets because they cannot contain the same elements. Now we have overlapping sets, which are the sets containing at least one common element. As you can see over here, we have A is equal to 1, 2, 3 and B is equal to 3, 4, 5. 3 is the common element, and as the sets are overlapping, they are drawn together, overlapping each other, and the common element, that is 3, is written within the overlapping region, and the remaining elements are written within the respective sets. The remaining elements of set A are 1 and 2, and the remaining elements of set B are 4 and 5. Finally, we have the universal set, that is a set containing all the elements that are under consideration for a particular situation. Universal set is denoted by capital U and is represented by a rectangle in Venn diagram. All the other sets, which are actually subsets of the universal set, are drawn within the rectangle. While universal set is represented by a rectangle, all the other sets, which are subsets of universal set, are represented by circles. Here it is to be noted that the elements 4 and 5, which are outside the circle, which means that they are not an element of set A. Set A contains 1, 2, 3. 1, 2 and 3 are a part of universal set, but the universal set also contains 4 and 5. So the elements 4 and 5, which are outside the circle but inside the rectangle, show that 4 and 5 are elements of the universal set. I hope that you found this video useful and you have learned about different types of sets. In our next video, we will discuss about different operations that are performed on sets, that is union, intersection, difference and complement.